All right, let me just recap what we did on Friday and then talk about what you guys can be working on today and what I have set as the plan as well. So let me just grab my planner. And I'll talk to you guys about what you guys would prefer to do as well. Let me just find it. There we go. Okay, so what we talked about on Friday was looking to get us up to that merit and excellence level criteria for the Redox internal. The way we were doing that was talking about these half equations and then putting them together for that full equation. So everything that's in red on this sheet is an example of what I need for the achieved. If you're aiming for a merit, then you need to add the next layer, which is looking at those half equations and looking at the justifications. What I'm looking at is if you justified reduction and if you justified oxidation, and it's either or of those two. So you're either telling me the electron number that's been lost or the change in oxidation number. So that's just being more specific in the detail. An achieved level student just gives me the definitions. The merit level student gives me the specifics to why it is that. And then the crazy thing about this assessment is that the excellence is not that much extra. It's just putting together your two half equations. So I would say aim for the excellence. Usually if you make a mistake, that's what's going to drop you down to a merit. So we looked at this example. We also looked at this example here. Now, these are going to be the templates that I will use for the assessment. I have printed off some more as well, so you guys can practice writing your Redox answer on the template itself, so that way you know how to format it. Are we okay with that so far? All right. Then I gave you some SciPad pages because I'm very mindful that you guys need lots of practice with these half equations to feel confident. We did some of the first few easy ones. So in this case, we were just doing the simple reactions, looking at the ions and the transfer of electrons. The other thing we were looking at is we used the oxidation numbers to help us justify. So we worked on page 98 and 99 last week. If you weren't here on Friday last week, I still suggest starting with these pages because they're really good kind of foundational pages to understand oxidation and reduction and what we're trying to do with these half equations. Are we okay so far? All right. Then in the last kind of 10 minutes of class, I started giving you guys the other SciPad pages with the half equations that are more complex. This was mainly, the idea behind this was for you guys to hopefully do these as homework to build your confidence in the more complex one. The reason why these guys are more complex is because you have to balance the reactive reagent, and now there's oxygen involved, and so you need to put water, and since you put water, you now need to put hydrogen, so it's got a few more steps to it. I did two as an examples, and I said do the rest as homework, but I don't know how many of you guys actually did that as homework. That was page 104. This is just me showing you how I worked out my oxidation numbers. Because the other thing I was doing was using the oxidation numbers to help us figure out oxidation and reduction. Page 105 is also those kind of more complex half equations. All right. Just honesty is the best policy. Did anyone actually do that for homework? No, that's okay. All right. So that helps me because that tells me that I should hold off on giving the net. Angela, do it? Look at that. All right. So I would suggest to basically get those 4 pages done. So 98, 99, 104, and 105. That would be what I would aim to kind of work on right now. You guys can also do 106 if you want. These ones are balancing the equation. Let me just focus it again. This one is doing redox balancing, but this is doing the simple redox balancing. So the stuff that was on page 98 and 99, you're just looking at the ions and putting those two things together. So if you want, you can move on to 106 and you'll be fine. Same thing with 107. With the observations, use your resource sheet to find them. So that way you guys can write that down. So that's what you guys can be working on. It goes actually to 108. And then where I will pick you guys up, you guys can probably do 110 as well, because that's just the same thing. What I will probably do then, once you guys have kind of solid understanding of what you're doing, is I might pick up the notes from page 111. Does that sound like a good plan for you guys? Yeah? All right. Other thing to keep in mind, I'm just looking at the number of days we have left in chemistry. I want to get your kind of feedback on it. Because I'm very mindful of what you guys can handle workload-wise. All right, here are the lessons we have left. So we have today. And this is week 9, so we're near the end. We have today, we have Tuesday, we have Friday, and then oh, come on, focus, will you? Then we only have Monday and Tuesday of week 9, or sorry, week 10. We lose Friday because of the mentor day. Monday and Friday. Oh, sorry, Tuesday. All right, so I just want to see how you guys have as your preference. So I am more or less done with the teaching of Redox. It's just mainly you guys having practice time. I will set Redox up the same way that I have set up like ion identification, where you get 2 shots at it. I will give you 4 questions total. I'll give you 2 questions. I'll give you feedback on those 2 questions, and then you'll attempt the other 2 questions. And the grade will be based off of the best 2 out of 4. Okay, do you want me to write that down? You're good, we got it? Okay. So the question for you guys is, do you want to finish this assessment before the end of this term, so that way you have nothing to worry about over the holidays, or do you guys feel like you would like the holidays to study and then finish it up next term? So the idea is, what we can do is study, first attempt, feedback, second attempt is the way we can do it if you want to do it that way. Yeah. Oh, okay, for this Friday. Okay. Just trying to think what's the best. How many are away on music tour? 1, 2, 3, 4, 5, 6. Okay. Not too many. All right. What I could do as well as an option, because I can just change the Redox questions, that's very easy for me to do. What I can do is study, first attempt, study or feedback, second attempt. If you don't feel ready for the second attempt on the Tuesday, I'm happy if you want to come back next term and do that. Does that sound like a good offer on plan? Okay. So we'll do our first attempt on Friday. Does that sound good? And the good news is, if you do well in that first attempt, then you don't have to worry about doing the second attempt. Those that are on the music trip, you can do your first attempt on Monday. Okay? So music people will go on this day. Sound good? And then we can do second attempt on Tuesday if you guys feel up to it. Or we can do it next term. Does that sound like an outline that we can work with? Okay. And music people, what I'll aim to do is I'll aim to mark your first attempt on that Monday night, so that way you can get the feedback back and you can decide whether or not you want to do it on the Tuesday, or if you want to hold off and do it next term. Okay, does that sound like a good plan? All right, cool. So I will let you guys have some time to do, I'll write which one you're going to do on the board. So SciPad pages, where'd you go? Oh, over here. 98, 99, 104. You can go all the way up to 110. I'll write that on the board. Chemistry class and science kids, I gotta remember you guys. I still need to be packing and cleaning up, so I'm going to state the try 3 before me rule. So try 3 things before you ask me a question, so that way I can pack up our room. Okay? So Google Classroom, internet, your friends, try something. Try 3 things, then come to me. Okay? Cool. You guys have some time to work, and I'll see how you guys go. All right, team, page 112. I'm going to go over one of those example problems so you guys know how to do it when you get to that point. The other thing I will do is I will transcribe it onto one of the assessment template sheets so you can see how you pull that information across. So I'll do question number 2. Now, in reality, on the assessment, you will just be given the reactants, and you're going to have to use the resource sheet to find the product, so just keep that in mind. And I don't even know if I have that as one of my products. No, I don't. All right, I'm just trying to think which one I do now. I'm just trying to think what's the best way to kind of do this. Okay, I'll just cover that up. We'll do question 3. Should we do question 3? Yeah, we'll do question 3. All right, team, listening up. So I'm going to do question 3 on page 112. And actually, I'll do the full thing, and I'll show you guys the products, and then I'll talk about what you do on the assessment template. So on this one here, they have given me carbon as a solid, and they've given me the sulfate, which is aqueous. And then I see carbon dioxide being produced and sulfur dioxide being produced, and they're both in the gas state. So when I make my observations, I would say that carbon, which I don't even know if I have on the resource sheet, to be fair. No, I don't. Carbon is going to be like the carbon that you have in your pencils. They're graphite, so that would be like a charcoal black. So if we're going to write our observations, charcoal, black, solid, added to colorless solution. With bubbles forming. Because if you see carbon dioxide and sulfur dioxide are both gases, and if I look at the resource sheet, they're both colorless gases. It's always good to mention bubbles because you can't see a gas, but you can see the bubbles. So I'm just putting that as like a note. Are we okay with that so far? Yes? Actually, no, I'll just keep going with this. All right. Next thing I need to do is figure out my oxidation half and my reduction half. That is when we're going to be using our oxidation numbers to help, because when we look at this, there's no clear ions being formed, so I can't use the ion charge as a way to do that. So first off, I look at my oxygens. All of these oxygens are in compounds or polyatomic ions. They are not in the elemental form. And on top of that, when I look at the exceptions to the rules, that equation doesn't have anything that's a peroxide or anything that has a fluorine in it. So you see when I'm looking at it, it's all in a compound or a polyatomic ion. It's not in the element form. It's not a peroxide. It's not with fluoride. So what that tells me is that all the oxygens are going to be -2. So -2 for all the oxygens is a nice little FYI. Since the oxidation number is not changing with oxygen, it is not involved in the redox reaction. You got how I got to that jump. All right, next thing I'm then going to do is work through the carbon and the sulfur, because those guys are going to be involved in this redox reaction. Carbon I can see over here is in the elemental form. So looking at the rules, if it's in its elemental form, the oxidation number is 0. This one here is in a compound. So it's going to, whatever the oxidation numbers add up to, it'll add up to 0. So since oxygen's -2 and I have 2 of them, that's -4. And if I want to add up to 0, this needs to be +4. So carbon's gone from 0 to +4. Agree with that? All right, has the oxidation number increased or decreased? Increase. So is that oxidation or reduction? Oxidation. Increase in oxidation number is oxidation. It is lost electrons in order to do that. So I could write that down as my oxidation half of the equation. I like to put my arrows nice in the center to make my life easy. So I'd be going C and CO2 for my oxidation half. All right, let's look at sulfur. So sulfur here is in sulfate. That's SO4 2 minus. So the the oxidation numbers add up to -2. I see that I have 4 oxygens and I have a -2 for those oxygens. So 4 times 2 equals -8. And whatever I add to that -8 needs to then equal -2. So what should I be adding for that? 6. So that one's +6. This one over here, I see I have sulfur dioxide. These guys need to add up to 0. So if I have -2 times 2 is -4, what do I need to add to get it to 0? +4. And do we see there, sorry, that's blurry, you guys. Do we see there how the oxidation number has decreased? We've gone from 6 to 4. So that is reduction. You should always have one oxidation and one reduction. If you have 2 of something, you've made a mistake. So I've assigned my oxidation and my reduction half. Questions, concerns, comments? We good to keep going? Okay. Next thing I need to do is go through my steps of how to do those redox equations. Both of these are complex equations because they both have more than just the atom that's involved in the redox reaction because I have oxygen. So first thing to check, are the carbons balanced? You have 1 and 1, so yes it is. There's oxygen on this side, there's no oxygen on this side, so I'm going to be adding what? H2O, how many? 2, because there's 2 oxygens there. All right, now that I've done that, I need to put what on this side? 4 hydrogen ions. All right, last step is to balance with my electrons so those the charges are equal. Everything on this side is 0. On this side, we have +4. So I need to take that +4 and bring it down to 0. So I'm adding 4 electrons to do that. And that matches what we said with the oxidation numbers, right? The oxidation number has increased by 4, so I should have lost 4 electrons. All these numbers should double check each other. So that's that equation. All right, let's do the one on the bottom. So this one here, are the sulfurs balanced? Yes. Oxygens? No. What am I going to do? Add water to which side? The right-hand side. How many? 2 again. All right, and then now that I've done that, what do I need to do? Put down 4 hydrogens, so that would be plus 4H plus. Cool. All right, last step is to add my electrons. On this side, it is 0. On this side, it is +2, so 2 more electrons on that side. Which again matches what we said with the oxidation numbers for the sulfur. It's gone from 6 to 4. It's decreased by 2. It has gained 2 electrons. Use these numbers to idiot check yourself. Okay? All right. Now, I don't really like how the SciPad has done this. I think it's really kind of redundant and kind of like repetitive. But what they want you to do on these two is just to do the multiplication so that way your numbers match with these electrons. So this is 4 and this is 2. I want them to be the same number. So the easiest way to do that is multiply the bottom by 2. So I'm just going to rewrite those equations with those changes. So that'd be 4 electrons plus 8 hydrogens plus 2 sulfates and then 2 sulfur dioxides plus 4 waters. I don't do anything to my top equation because my top equation was fine. So I have H2O, 2 of them, plus carbon, CO2, plus 4 hydrogens. There should be 4 there, plus 4 electrons. Are we okay with how I got to that point? Right, now I gotta put it together. Now this is one of the more complex equations. So I need to make sure the electrons cancel out, but I also have some waters that can cancel out and some hydrogens that can cancel out. So start with the electrons. Electrons and electrons cancel out. I have 2 waters on this side, I have 4 on this side. So I'm gonna get rid of these 2 waters, and I've subtracted 2 away from here, so that's now a 2. Are we okay with how I did that? I looked to see what was on opposite sides of the equation, and since there's 2 here and 4 here, I can get rid of these 2, and I can get rid of 2 from this side. The last thing are my hydrogen ions. There's 8 on this side, there's 4 on this side. I can get rid of all 4 of these, and since I've gotten rid of 4 of these on this side, I'm going to take away 4 on this side as well, on the opposite. And then I just put it all together. So I have carbon plus 4 hydrogen ions plus 2 sulfates has carbon dioxide plus 2 SO2 plus 2 H2O. If you want, again, it's another way you can kind of idiot check yourself. You can make sure that your oxygen numbers match on both sides, hydrogen number matches on both sides, sulfur and carbon matches on both sides. So that's 4, and that's 4 hydrogen. That's 4 hydrogens. That's 4 hydrogens. That's 8 oxygens. That's 1, 2, 3, 4, 5, 6, 7, 8 oxygens. So they all balance. So that's the nice thing about this is that you can double check yourself very easily. All right, questions, concerns, or comments? All right. With this resource sheet, what you guys can do is take this information here and you can actually put it onto the assessment template so you have practice writing it up. So for example, what I would be doing, and let me get the achieve, merit, and excellence stuff out. So if I was just aiming for achieved, I want to use these practice questions to help me write up. I would have my observations. Now keep in mind with the observations, when you guys get these practice questions, we will only give you the reactants, but we will tell you what's happening observation-wise. So I will tell you that there are bubbles forming. So basically what you'd have in your observations is solid black is added to a colorless solution, and colorless bubbles form. That's an example statement that I could give you on the assessment, and I would tell you that you are reacting carbon with, it's probably going to be something like, maybe you get sodium sulfate. So that would be like the information that I gave you. And then we would tie our observations together. So the solid black, that there is the carbon. The colorless solution is the sodium sulfate, which is aqueous. And then I would use that information on my resource sheet to figure out what my products are. In this example, we've told you the products, but in the actual assessment, we will not tell you the products. So I would look at, so carbon isn't on this list, unfortunately, but that is the bubbles. One of them is carbon dioxide. Now, when we're trying to decide if it's the sodium or the sulfate that's reacting, if I look, I don't think I put sodium on here either. There's no metal that's forming, there's no solids that's forming, so that eliminates sodium as being part of the reaction. if I look at SO4, there's lots of choices with what SO4 can become. But what I see is that since it's becoming a gas, that must be SO2 that's forming. Are we okay with that? Right. Other things that I need for achieved is the identification of oxidation and reduction. This is a harder question, and you have to use oxidation numbers to figure out oxidation and reduction. So what I will be likely doing on the assessment is giving you one hard equation and one easy equation, so that way you can still figure out oxidation and reduction without the oxidation numbers. But from the work from the SciPad, we have figured out that the oxidation reaction was carbon going to carbon dioxide. And we also figured out the sulfate going to sulfur dioxide is the reduction. And then the last thing I need for the achieved, sorry, should copy this down too. Identify oxidant and reductant. So that's the reductant. That's the that's the oxidant. That's the reductant. Justification. So again, just using your definitions. This one has gained electrons, or you can say that the oxidation number is decreased. This one over here, you write down lost electrons, oxidation number increased. So you got that written down, that would be the achieved. Just watching the time. I'm going quite quickly because I'm mindful that the bell's gonna go. All right, if I want to get this up to a merit level, I need to start talking about oxidation numbers and specific number of gain of electrons or loss of electrons. We've done this on the previous page, so I'm just transferring it over. We notice that this one, the oxidation number is decreasing by 2. We've gone from +6 to +4. This has gained 2 electrons. On this side here, the oxidation number has increased by 4. We've gone from 0 to +4. We have lost 4 electrons. So that detail is required for the merit. The last thing I need then for the merit is your half equations, which is what we did over here. So carbon plus H2O, we added 2. They do need to be balanced if you're aiming for that. So those are my half equations. That gets me now up to merit. If I want to get up to excellence, I'm putting these equations together. I'm multiplying this bottom half by 2. So like I said, that became 4, that became 8, that became 2, that became 2, that became 4. And then we put the whole thing together. Electrons cancel out. That now goes back to a 4 because that cancels out. That goes back to a 2 because that cancels out. So I would have C plus 4H plus 2SO4 2 minus becomes CO2 plus 2SO4, sorry, 2SO2 plus 2H2O. That's what you need for excellence. All right, I'm mindful the bell's going to go soon. If you guys want to grab any practice templates so you can write some of these SciPad questions on the template that you're going to get for the assessment, you're more than welcome to grab some. Grab as many as you want because I've printed like 60 of them. And then just keep practicing. We'll have another study day tomorrow, and then Friday I'll give you guys your first attempt.